I thought we could all enjoy a little bit of classical music, but revisited in a more electronic form. I actually enjoy writing music also. But the reason I presented that was to just talk about the fact that typically when we talk about visualizations or computers in general, we tend to dismiss anything that is more than a few years old. We want the latest, greatest. But then we can find really some gems in the history of visualization. And speaking of history, what is interesting is that for the stem and leaf plot, we just need one thing, the digit, the numbers, 0 through 9. However, we can improve on that in certain ways by adding some graphical elements. And just mentioning the numbers, from medieval times all the way to the 14th century, the changes were quite abrupt, and many of them. However, from the 14th century up to our day, the digits in our type of scripts, the glyphs are the same. So it got to a point where people were comfortable with it. And what it means is that really it's effective. So as far as graphs and bar charts, we can find some as early as the 1300s. Nicole Dorem in a Latin manuscript, which was printed, this is a printed copy from the 1480s, introduced some of these charts, and really it is to talk about, it says latitudinibus, which really it's the horizontal movement, or the velocity and acceleration. Even before Isaac Newton, he was considering these things interesting, right? But there are also elements that are tabular or graphical or semi-graphical, but are not stem and leaf plots. So if we look at, for example, bus transfers or timetables in general, look like they are arranged a little bit like a stem and leaf plot. And even though Wikipedia might tell you that there are some stem and leaf plots that are timetables, in reality the stem and leaf plot is supposed to be a distribution plot, and the timetable is not. The purpose of it is not that. So it's a little bit different. However, they do look similar. In fact, in one publication from 1919, we see this chart, and if I zoom in a little bit, we'll see. And these are numbers. And I could have also add maybe perhaps area charts, and we would have seen perhaps a legend on the side giving us more detail, but we had to go back and forth, back and forth. Here we see the numbers directly. But again, it's not quite a stem and leaf plot. And if we continue over, there we go, 1946, Dudley had a book for engineers where he's basically producing a transcription table. So that transcription table has columns. However, since they are not stacked, it's not yet quite the stem and leaf plot. And of course, as far as graphical representation, sometimes it's very valid. In fact, Jacques Bertin in 1967 introduced a book that in English is named The Semiology of Graphics. If you don't have a copy of that, I would definitely recommend it. It's a great book. And he introduced some concept of sorting based on visual cues instead of sorting by value, like by age or by amount of theft in this case, which was the information that he wanted. And then he could see some kind of linear relationship across. So sometimes it's worth it. But we can also go overboard when we are doing graphics. Roberto Bacci in 1968 introduced this concept of graphical rational patterns. So this is a little harder to read than numbers. Everybody agree? All right. So, I mean, it was an interesting concept, but perhaps taken a little too far. So in 1970, in the classroom, John Tukey introduces the stem and leaf plot. What's interesting to note is that to this day, it is used in the classroom, and as early as the 4th grade in North Carolina, I believe it's starting in the 5th grade that they introduced them to this plot. If we continue in 1972, he published a paper that gave a little more traction to his concept in basically a book for George Snedecor, some graphic and some graphic display. And of course, in 1975, Hoagland, a colleague of his, wrote some Fortran code to be able to generate the stem and leaf plot. But really, this is the book in 1977 that he ended up publishing with the stem and leaf plot, and it also covers the box plot. So again, this is kind of one of those very important book in the history of statistical graphs as far as that is concerned. But there was a danger lurking. And what is the danger? It comes in the form of something we called a floppy, or a floppy disk. Yes. And why is that a danger? Anybody who wants to venture a guess? Well, in 1977, the Apple II came out. Initially, it was with cassette, so storing data on cassette was kind of awkward, and nobody would want to store a lot of information because you weren't sure you were getting it back. However, with the floppy, now you could generate with your computer pseudo-random numbers and create large amount of data. Well, big data for the time, right? I mean, although it's probably about 100K here. Still, that meant that the democratization of computers, such as a Commodore 64, even less expensive, or in businesses like the IBM PC with its CGA color display, that was basically trouble for the stem and leaf plot because it was text on the console, green screen, right? And at most 300 data point. What do we do beyond that? But at the same time, there were some people that were holding on into the beauty of the design. Understanding robust and exploratory data analysis mentioned several points as to why it is so effective. And I won't go into all the details because we wouldn't have time. And Edward Tufte, also in the visual display of quantitative information, makes a mention how the glyph of the digit is so effective. And of course, he's a big fan of data to ink ratio. So if you're putting ink on paper, it better represent data. In fact, I experienced that firsthand talking to him, and that was kind of a, all right, I got this incredible new plot, I'm going to show it to him, and he's going to be like, oh yes, this is marvelous. And that's actually not what happened. So he said, well, your font is horrible. What kind of font are you using? And, well, the colors, wow, they're way too intense. You know, dim that a little bit. And so that was the message that he gave me. So I went back home and was like, okay, well, I guess he's right. Because we are so caught up sometimes in the technology or whatever we've been working on that we're focusing on one aspect. But in reality, we have to look at everything. So we worked on that and continued on. So if we look at perhaps a demo, right? It's better than just always talking about these things. First, distribution plots. I'm sure you know most of them. I won't go into the detail of the data that I'm capturing here, but basically Medicare payments for 2012 and your typical pandas manipulations. We'll look at one HCPCS code, which is 94640, which represents a nebulizer treatment. Let's see if I can bump the font a little bit. And if we run a histogram, well, we have kind of an idea of the distribution, and it appears that there were charges from maybe 0, we don't know for sure, all the way to, well, perhaps 400, but we can't really tell, right? If we look at other distribution plot, perhaps you're familiar with the rug plot. Basically these little lines, each line is an observation. And of course when they are very dense, such as on this side, it's hard to actually see the individual detail. Strip plot, same concept. But there are also distribution plots that are pretty effective, such as this one from Seaborn, that goes into a bit more detail. Plus, it allows us to do secondary graphs, such as perhaps a KDE in this case, or a KDE inner rug plot combining. Oh yes, perhaps I should mention the last one, the box plot, right? Another, actually, as I mentioned, John Tukey's invention there. So this data gives me a lot more detail, but some people don't like it. Personally, I like it, but what do you do to get from that point to actually see the data? Well, so the stem and leaf plot allows you, and this is the output of Stemgraphic here, allows us to see the individual data point. So on the extreme left is the aggregate. It's a count, so basically it's telling me how many records I got on the first row, up to second row, up to third row, so on, all the way to the top. It's saying that I have 900 data point in that little chart here. And I can actually read the individual values. I can also tell you that $40 is the median right here, and that $50 seems to be a pretty popular payment that is requested. And all of that from the little distribution plot. So let's dig a little bit deeper into that. So Stemgraphic is a Python module installable from pip3 install Stemgraphic. And once you install it, current version is 0.3.3. You can also get your help on it on the package itself or on the individual functions. There's also a command line tool that's associated with it. And the command line tool allows me to, for example, I'm listing, I got one Excel file here. I will run stem on the Excel file, and stem automatically looked at what's the first numerical field that is not looking like an index. Unfortunately, that one wasn't very exciting, but I know for a fact that there are some dollars in the 7th column. So I'll pass that and see what I can see there. And now it goes from 20,000 all the way to 200,000. Of course, I'm on the command line, so it's text. But there are other methods or functions available. One is stemhist, one is stemkde, stemline, and Stemgraphic itself. So when I started looking into that, I was reading over last year, over the holiday, John Tukey's book, and I was like, why is it not used? And I started looking, and on Rosetta Code, there were like hundreds of different implementations in every language you can think of. And so that was the data set here that they were using. It's a list, a plain Python list here. And so I decided to see if I could replicate that, and it looked pretty nice overall. And of course, I decided that I should be able to change the colors of the different elements and make it a little more flexible from that perspective. It also works on synthetic data or any data really. In this case, I'm just generating NumPy arrays, and the data here will be rendered. In this case, I decided to replace the bar by underline in orange, different color. It's pretty simple. I just add a few keywords to do that. There's quite a bit of flexibility. Or I could do a histogram, a black histogram, like this. Of course, now I've lost my significant glyph, which is the digit. So I can no longer see the exact values. But because it also is using Matplotlib in this case, it can use savefig and save to a PDF, SVG, PNG, or whatever other format that I would like. What about if I like R and I want to do my data munging in R? Well, I can do that too, and in this case I just wanted for the brevity, I put it in the same notebook, but it could be in a separate notebook. But in this case, I'm actually using RMagic from RPY2, and that way I can pull, which I did two things here, right? Let me bump the size a little bit. I actually got the data set MT cars, motor trend cars, classic, and I got just the car weight from that set, and then also I got the whole Quake set, which if you've attended the tutorials yesterday, there was one tutorial that covered that set in particular, so I figured, well, let's include that one too. And so if I plot that, I actually see the multi-model approach here. And again, we have quite a bit of data here. We have actually 900 points here again. If I look at the car weight, there was only 32, and that's because the set only includes that many. But I can clearly see the min and max here, which are about 1,500 pounds and 5424 pounds for the heavier vehicle. So again, I can do some basic and not so basic quick look at my data this way. I can even, hey, I did mention I would introduce a new programming language you hadn't heard of today, or maybe you've heard of it. It's Coconut, which is functional programming in Python, compatible with Python actually. So I can actually use Python statements and do a pipeline. In this case, I'm just pushing from this side all the way to Stemgraphic. So I'm actually sampling 100 from this list that's generated by this here. So this is kind of a convoluted example, but just to say that, yeah, there's a level of compatibility if you can bring it into your notebook environment here. Alrighty. Briefly on the design and implementation, I just wanted to mention it looks fairly simple, but when you start looking at how to count the number of bins, and you'll see in the performance demo why that is important, the number of bins is how many data points you'll accumulate in each, or how you're going to slice and dice your data. And if you don't get it right, you can get from somewhat informative visual display, or to basically, okay, this is useless to me. So that's pretty important to look at that. So I took a hybrid approach based on the number of points that are to be counted. So for a smaller data set, I take one approach. And if you want more detail, it's in the little booklet. And if you didn't get a copy of the booklet, there's a few more copies. So after the talk, feel free to stop and grab one. Okay, number of data points. This is where you're wondering, this guy is talking about 300 data point, 900 data point. I have 1,000,000 data point, or 750, or 150 million, or 1 billion data point. What can this tool do for me? Well, so this is where sampling and other techniques come into play. And I won't go into the detail yet. I will continue on to the next demo, and it'll make a little more sense. One thing also, so of course you have to consider when you create a new visualization, how am I going to inform the reader or the person looking at this chart, how it works. So a legend, that's important to have, so we spent some time thinking about that. Well, I'm saying we, I mean it was me basically. So secondary plots also, again, because we saw in Seaborn how convenient that can be. In fact, you could maybe in Seaborn maybe have a normal curve or a double gamma and all that and compare, and it's like, oh yeah, this exact same distribution, right? Persistence. So since we are sampling, one of the interesting features is that maybe you don't want to do the data wrangling. It handles quite a bit already. It figures the first column, it'll take that, it'll sample. It would be nice to be able to save that sample and not just have it for the visual display, that I can continue my analysis from that sample. Particularly if I'm talking about a set that's 1 billion records, I don't want to have to query that too often. And the defaults, well, I mentioned, you know, as Tukey mentioned, oh, font ugly, color too bright. So you have to think about these things. Performance demo. When I say performance, there are many aspects of performance. One is the speed at which things run. But also, so I just loaded 700,000 records. Look at the histogram. So Pandas has a very fast histogram. It also has a plot that will, by default, do, it looks almost like a histogram that's not sorted. So I could, in theory, maybe sort it and have something useful. But it's also a little slower. According to time it, once it's done, it'll tell me it takes about 5 seconds per. Oh, 4.37. So that's actually a little bit better than usual. And I'm running everything off of a little USB hard disk, external, just so you know. So now I'm importing Seaborn, and we'll look at the disk plot that we demoed earlier. Oh, what's happening? Should I panic? No. I know actually what's going on. Basically, Seaborn is telling me that there are values that are undefined right here. And so what I have to do is drop NA before I actually call the plot itself. So if I didn't know that, well, I would lose some time or so on and so forth. So let's see how it did. Ooh. It looks like just one bar. There's a little bit of detail here, and I can see the max value, but there's not a lot of information on this screen. And so that's too bad. Let's see how Stemgraphic does. First of all, it took 200 milliseconds, about the same or a little faster than this plot. But let's see what it did find for us. So the minimum value is 0. The maximum, and I shrunk the screen so you guys can see here on the screen, but it's 5.26, so on and so forth, $1 million. And I can see the individual data point. I can see my median. And so I get really some informative display with basically default behavior, except for me adding the random state so I can reproduce the same graph for every time I do this presentation. And it ran it multiple times. So let's make Excel cry. 12.5 million rows. New York City, yellow taxi trips data. For 2015, we'll look at just, because this is a live demo and we won't have that much time, we'll just run on 1 month. So 12 million rows instead of 150 million. And so just I have a little class here to time this. By the way, if I were to look at the data through word count, anybody familiar with word count? And while word count does its thing, WC is basically just doing that exactly. It's giving me the number of lines, words, and bytes in that file. And it took 7.6 seconds, which is pretty good for 12 million records, right? It's a pretty big file. And so if we run Stemgraphic on the same data, of course I have to load it in Pandas, so it'll take a little while, obviously, right? But what it will do is it'll go through that data, figure out what's the minimum, the maximum value, how many records are there, and we'll build the graph. Oh, it actually came back in 17 seconds. Not too bad. So I knew that. So all right. So we did get an output fairly quickly. Now let's look at the larger data set, and that's the 150 million records. As I mentioned, I've already run this because it takes a little longer. Even just looking at word count on this and timing it, it ran it a few times, and the best time was 4 minutes and 50 seconds. So that's a C program optimized for doing one job, and it took almost 5 minutes. Pandas, if we loop through the 12 files and just read them, and that's all we do, we just load them into memory and then go to the next, took 8.5 minutes. And the last one, Stemgraphic from disk, again, running this. Now, here's what's happening. Because it is way more than the RAM on the laptop, it requires 60 gig of RAM minimum. Actually, I was able to load it on one node that has 64 gig, and it was able to load all the data for New York City 2015. So it's bigger than the RAM. So pandas will not work. So I'm using, what's that DD thing that I'm using? If we go back at the top, import Dask data frame as DD. And so Dask allows me to have a data frame that's on disk. In this case, however, even better than this is that I could also, instead of doing read CSV, I could do it from HDFS. So if you have a Hadoop cluster or basically any cluster that has HDFS capability, or you could use S3 or so on and so forth, then you can actually pull the data, and you can, whereas this took 6 minutes, you could actually, given enough node, make this interactive. And that is pretty significant. Of course, there are other visualization tools that are able to handle very large data. Sarah mentioned Data Shader yesterday. But again, this is a tool that's very simple to use. The only difference is instead of using my pandas data frame, I'm using the Dask data frame for very large set. And Stemgraphic knows about that. Now remember I said sampling, I'll go back to that. So in terms of the sampling, what's happening there is that Dask actually does things a little different than pandas. In fact, if I could make one change, I might suggest one change to the code. I had to use a fraction and not the actual number of samples I wanted. And what that means is I'm required to get the count of data, do the division to get the fraction that I want, and pass that to Dask, and then execute that, because Dask is building just intent, and then you have to do .compute to actually do the thing that you want to do. So it's built into Stemgraphic, so it knows about, as I mentioned, lists, NumPy, it knows about data frames, and Dask data frames from that perspective. And again, as I mentioned, performance is not just about the time it takes, it's about how good the tool is. I mean, if I have to spend another hour drilling and figuring out what it's spitting out to me, then that's not really useful. But these graphs are used on a regular basis, and really, it's very effective. One of the things that I've built also is that when it samples and it gets back and it calculates the ratio and it's tried to figure out how many rows or and columns and how it will look, if it thinks it's like, no, that's not going to be visually appealing or unusable, that means there's a good chance that the sampling hit one of those edge cases, right? I mean, there's always, if you sample enough times, you'll get a sample that's not really representative of your data. It happens from time to time. So what I did is I just added something very simple, which is a secondary sampling. I would love to see people try to pass their own functions and try to experiment with that and see what else can be done from that perspective. So that's part of the future work, and since I've put everything on GitHub, then you can also go and help out and try to figure out. There's quite a large to-do actually. So maybe, speaking of large, need to bump it up a little bit. Again, so that means that you can actually look at the code, try to figure out how it works if you want, or just use it as it is, pip install, and you have access to it. It's only tested on Python 3, and you might think, wow, that guy is kind of like not friendly, right? Just to know that many of the projects are actually all aligning themselves to basically start offering within some months or even a year in certain cases, Python 3 only. And since I had a limited amount of time to develop this, I figured, well, I've been using Python 3 exclusively for over a year now. I think it's okay. So, alrighty. So that pretty much concludes the presentation. Any questions from the audience? All right. Just wait for the microphone.
So sometimes there's more than one line, like there's like a blank line that doesn't have a number next to it.
Yes.
And there's a bunch of stuff on the right, and I wasn't quite sure how to interpret that when that happens.
Yes, and so in the booklet it explains a little bit more, but what it is that John Tukey, when he designed his stem and leaf plot, he defined from the get-go 3 different approach to this. One is the simplest, which is just I have the digit and the first on the stem. I do so stem dot leaf times the scale. Let's say the scale is 100, so I have 2.1 times 100, 21. In the case of plots that are maybe too squished and you want to gain a little bit more vertical, so this is the number of bins that a histogram would calculate. In this case, what we do is split from 0 to 4 on the first, or if there's no data, it actually just skips it if it's the first line at the bottom, or if it's the last one at the end and it's 5 and above. So 0 to 4, 5 and above, 5 to 9 on the second line. There's actually one more, even more split graph plot, and that goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Already this, when you go and split it, what I've found out is that people have a hard time associating which line goes which. And so I don't use it much beyond EDA work. So when I'm exploring data, I'm looking at the data, I'll use maybe the split. But if I'm publishing for somebody, if it's appropriate, if they actually want to see the number. And part of the future work that I pointed at is research in perception, which is one thing. Also research on persuasive power of text and graphical elements. Because it's been shown that if you have a lot of visual aspects but not a lot of numbers, people are wondering a little bit more about your data, if it's true or what. But if particularly in financial areas, and whereas if you have a table with a bunch of numbers, oh, this looks very serious. So apparently there might be an impact by having visual and colors, and at the same time the actual numbers on the chart. That's an unproven theory at this point, but it would be interesting to look at.
Thank you, great talk. The stem and leaf plot was really designed for typographic representation data. It's a static thing. In today's age with interactive graphics, have you thought of perhaps having just a histogram, but if you mouse over, it becomes a stem and leaf and people can see the data, so it becomes more interactive that way?
Yes, actually, so I've been talking with Sarah quite a bit on bokeh, and I've actually been using bokeh for quite a while also, but I didn't feel comfortable enough with it when I started that, which was back in January of this year, to try to do that right away. I had some more algorithmic problems to solve, the distributed computing issues, things like that. But yeah, definitely it's also on the big to-do list on the GitHub repo. Definitely interactivity would be quite marvelous for sure.
So thank you for this. When I look at this, I see like a visual representation of like descriptive statistics, right? You've got your min, max, you've got your distribution. Maybe it's a standard deviation. You can sort of visually see what you might get in like a like Panda's description. But descriptive, that can always hide. That can hide part of the nuance of the data. Like what do you like to combine this with to really get a sense of your data? What do you think it's good for? What do you think it's not good for?
Yes. Okay. So first of all, like transactions in dollars and things like that tend to have a distribution that it lends itself well to these things. I've been looking a ton at Medicare data, things like that, and you see patterns. It's like it raises questions, things that you didn't expect to find necessarily. It's like, why is there such a peak in this area? Or why this number shows up so many times. This is like not normal. There's something weird there. And for sure, I would want to investigate more. So there are some areas like that that work out pretty good. When you have very few data points, I mean less than 30, I don't think it's worth the effort to or the time to use that. And there are data that basically just a table is the best approach. I mean, you just have some numbers that you want to show, and that's the goal, then might as well do that. But when you do want to, again, salaries, house prices. So yesterday there was a tutorial Don and I did on house prices, and you could clearly see the distribution of the house prices in Seattle based on the data, and it was fairly informative. So right away you can see these patterns emerging. Now, even better would be maybe to combine clustering and colors based on these clusters and things like that automatically. Then it would provide even more information, obviously. And because it's a graphical representation, then that should be possible. All right.
I think if we don't have any more questions, then our time is up. Let's give a big hand for Francois and Dion for